So the fault tolerance. Yesterday we learned about the high availability, and then the fault tolerance is a concept which is something similar to high availability, but it is more related to the virtual machine. Okay. So the aim of fault tolerance is very similar to high availability, but in terms of availability, it is 100%. It has 0% downtime. Okay, that means not 0%. I will say. I think 2-3 millisecond downtime is there, but it won't be. You won't be perceived. So, as if we say high availability, then we have a availability of 99.999%. But if we talk about the availability in terms of fault tolerance or fault tolerance ability, then it will be 100% fault tolerance. It is not measurable. So that means your machine will always be available, and it will, even if it goes down or restart, the user will never suffer from any loss of data or any lack of service. So fault tolerance and high availability has 2 points. High availability is related to the host, and fault tolerance is related to the VM. So this is important. Okay. This is, so the fault tolerance, what we do, what the VMware does, there are many standby virtual machines will be there. And so that if one VM go off, then the next VM, the another standby secondary VM will bring into the picture. And there can be more than one secondary VM. There can be 3-4 secondary VM, depend on how mission critical your application is. So fault tolerance is expensive thing, because any VM you are going to create a replica of that VM, and all the time the replication is happening. Every millisecond replication is happening. If I am writing 1, 2, 3, 4, 5 here in one VM, then the secondary VM will at least have 1, 2, 3, 4. The fifth one, if it has not finished the writing, then if it has finished the writing, then it will also be available to the secondary VM. So this kind of fault tolerance is used really for mission critical system. In general, the fault tolerance is not used. High availability is used. So mission critical means if someone is having the surgery, like you probably have, if you have seen the Money Heist or La Papir or what, yeah, that is the name in the Netflix series, where they were doing the surgery of who? Forgot the name. It was in Moscow. Who? Anyway, so they were doing this surgery by using the internet calling, and then suddenly the internet call went away and the person was lying open. So that nowadays a lot of robotic surgery is happening. So experts are at various places and they are using the robotic arm sitting at their place, and the surgery they are doing to the patient, and really it is happening. And in those kind of condition, and everything is happening via the cloud. And in that situation, if we only have one VM, which is actually on which the software is running for robotic hand control, and that VM suddenly goes away. In that kind of scenario, this fault tolerance is very, very necessary. Or in autopilot system, if something is driving in autopilot mode, and if the VM suddenly, which is actually running the software, crashes or underlying element crashes, then the whole this autopilot or autonomous vehicle, maybe it is an aircraft or car or even the autonomous ship, can crash. Or a spacecraft mission. A lot of spacecraft has very mission critical system. So in those kind of situation, the fault tolerance become necessary. In general, the fault tolerance are not used. It only required for very important system, which is really, really important to have that kind of fault tolerance. Then now, how does the fault tolerance work? So it works in the VMware. They are using this called Lockstep technology, and using the Lockstep technology, they are using the fault tolerance. So it means that there are one virtual machine, and it also has a secondary virtual machine. These two virtual machines will be locked in the Lockstep. They have a technology called Lockstep, so they are locked. And so anything which is written here will be getting replicated in a millisecond to the other system. And once if one VM crashes, then the secondary VM, in secondary virtual machine will be created with the fault tolerance technology. And if one VM crashes, then immediately the secondary VM will be made the primary virtual machine, and they will continue the work. And if the secondary VM, which became the primary VM, and that also crashes, then the next secondary VM will be taken over and become the primary virtual machine. So it depends on how many level of fault tolerance has been taken care. Usually, if people go for fault tolerance, they go for 2 to 3 level of fault tolerance. Means they will only not go for 2 virtual machines. They will go for at least 2 additional virtual machines. It's very much like we are driving a car, and when we go for a long drive, and then we have one way to avoid the fault tolerance is that if our car go not working, then we carry 2, 3, 4 car. Many people who have a requirement of time critical, they do carry 3, 4 cars. Some for safety reason, other for this kind of situation. If one car does not work or get malfunction, then immediately they will switch to the next car, and that will take to them to the mission critical destination. Like Mark Zuckerberg or Facebook CEO or Amazon Jeff Bezos, they make millions in every second, and they would not like to lose time for their business meetings. So that kind of thing, they carry multiple cars. But as a normal people, we do have the fault tolerance. In our car, we have additional tires. If the tire burst, then we use stepney and replace the tire and go ahead. We do have some downtime there, or high availability point is there. So in the VM world, if for mission critical, they use the fault tolerance technology of Lockstep, where they lock the primary and secondary VMs. And this VM will be the secondary VM will be the exact replica. And the who is going to decide that the primary VM went off and secondary VM will be now the primary VM, or how to make the replication. This all is done by another thing which we will learn on next Thursday, called distributed resource scheduler, and that take care of arrangement or replication from primary to secondary VM. So at any point of time, there will be a secondary VM which will be the exact copy of the primary VM with a small lag of millisecond. It's not 100% replica, it will be a small lag. So in a fault tolerance virtual machine, the secondary copies are not allowed to run. That means even if we have the primary VM and the secondary VM and many secondary VMs, but at any point of time, the actionable virtual machine will be the primary VM. The secondary VM will be just making the replica. They will not be used to take any action, and even the primary VM will be not aware of that there is a secondary VMs, because there are replication controllers are there, which is going to do the replication. It is not the primary VM task to replicate itself. This restriction will ensure that host failure cannot result in the loss of both the VM. So if This will help that if one of the VM crashes, if all the copies are running together and on the same host, so that means the primary virtual machine and the secondary virtual machine will not be on the same host. So that means they will not be on the same physical hardware. So if one VM is running, primary VM is running on one physical host hardware, then the secondary VM is made in another place, preferably on a different data center. So that if that crashes, then the other will not be crashing. So they both are available. Now, as I said, the primary and secondary work in the Lockstep technology, and that Lockstep captures the current state and the event of the primary VM, and then it sends them to the secondary VM. So in that case, if primary goes down, spelling mistake, then instantly the secondary VM will take over and continue its operation. And that means to have a fault tolerance, we need an extra standby virtual machine. And because of it, it is a costlier solution. When we have one VM to manage fault tolerance, we can go for another VM. But in generally, when we are going for a cloud, then there can be a few thousand VMs, and we won't be able to. We are going to the cloud to reduce the cost, right? And if our requirement is not mission critical, then why should we increasing just that we to say that we are a fault tolerant system. High availability is anyway taking care of the thing. So how it does? So if we have this primary VM, and at the point in time instance n, whatever it will be, whatever is the condition of the VM here, secondary VM will have n-1 condition. That means if it is writing 1, 2, 3, 4, 5, then it will also have 1, 2, 3, 4. So once it finishes writing 5, then it will also be having 1, 2, 3, 4, 5. And to do this, there is a software controllers are there. So if this is a primary VM and if it is a secondary VM, so there is a storage network will be there, which is going to copy replica of the data store of the primary VM. There will be a replica of secondary data store for secondary VM. And as we know that all this is activity of primary and the secondary is happening in a different host. They are not on the same host. So storage network is only going to do a replication of primary data store to secondary data store. But then the fault tolerance logging network is there, which is going to log the current state of the VM. And in the secondary side, there also will be the replication of the current state of the VM, like what is the logs are there, what are other conditions are there. This will only have the data store, but everything else condition will be there in the secondary VM, and it is managed via this fault tolerance logging network. But everything, this is only for logging, this is only for storage replication, but there is a management network which actually checks every few seconds, preferably 5 seconds is default. It checks every 5 seconds and the heartbeat. Remember, we study in the architecture of the cloud computing, heartbeat. So depending it every few seconds, it is checking the heartbeat, whether who is alive and who is not alive. And this management network will be telling to the fault tolerance software that the primary VM has gone down. Now give the control to the secondary VM and make it a primary VM. Is that okay? Okay. Thank you. But now we are talking about multiple VMs, right? There's a primary VM and there's a secondary VM. There can be another secondary VM. And if all the VMs will start working together, and that is fault tolerance avoid, that situation is called split brain, when more than one VM is acting as a primary VM. And that if that is a condition, then that means two active copies of VM situation is not good for recovery from a failure. So in fault tolerance technology, they avoid split brain situation. They take a lot of aspect into the consideration to avoid this split brain situation. Again, I will highlight again, fault tolerance work at the VM level, and you can enable and disable the fault tolerance on the virtual machine. So if you are using the VMware thing and creating the fault tolerance of virtual machine, you are creating multiple VMs for having a fault tolerance. You can have a fault tolerance while creation of the virtual machine, or even the VM is created and you want fault tolerance of that VM, then you can enable, or if you don't want it, you can disable the fault tolerance of that particular VM. Primary and secondary VM will continually exchange the heartbeat via this management network, not directly. And this exchange allows the VM pair to monitor the status of one another to ensure that fault tolerance is maintained continually. So this is a small overview of very key aspect of how the fault tolerance is maintained. But as we know that there is a small concept, virtual machine template, because we are talking about creation of primary VM and secondary VM and lots of VM. And in colloquium also, you have seen that there is an Azure called ARM template. There are templates by which you can create. So in VMware also, there are virtual machine templates are there, and which can be used to configure exactly the same VM every time you want to make a VM. So this, once we have created a VM environment and we want, let's say the secondary VM or the another secondary VM to have the similar environment, so that can be created using the virtual machine template. So once we configured one VM properly, then create a template of it, and every time you want the same kind of VM, you simply use this template to create. And this can be used to rapidly deploy a large number of new virtual machines. So a user don't have to sit and make the VM. It can be done automatically. So this was a small overview of this fault tolerance. Distributed resource scheduler, we will study